Offset function. Do you know what would make our life easier? Well, I'm sure we can think of a lot of things that would. Let me rephrase that. What would make it easy to break down large amounts of data and reference data ranges or single cells in Excel? The answer to this question brings me to the offset function. This lesson is going to focus on the basic functionality of the offset function while teaching us to implement and apply the offset function to various uses. What is the offset function? Offset is a built-in function in Excel that returns the reference to a range of cells having a fixed number of rows or columns. The reference value returned can either be a specific cell or a range of cells. To put it in layman terms, offset returns a single cell or range of cells that act as a reference to a range of cells with a specific number of rows and columns. Let us take a look at the syntax. Reference is a required parameter. It provides the base value for the reference and could refer to a cell or a range of cells. Rows is a required parameter. It provides the value of the number of rows where the upper left cell of the reference range will lie from the reference. The value of the rows parameter can be positive or negative, which can mean rows move below the starting point or rows move above starting point respectively. Cols is a required parameter. It provides the value of the number of columns where the upper left cell of the reference range of cells will lie from the reference. This parameter can be positive or negative. Just like the rows parameter, each has different consequences. A positive value implies that we move to the right of the starting point, and a negative value implies that we move to the left of the starting point. Remember that offset does not move the contents of the cell, but merely provides a reference. Height is an optional parameter. This parameter defines the number of rows, which would account as the height of the return reference. Weight is an optional parameter. This parameter defines the number of columns that would account as the width of the return reference. Both height and width are only positive values. If these parameters are not mentioned, Excel by default assumes that the offset has the same height and width of the reference. Now that we are aware of the syntax and working of the offset function, let us implement it. Implementing the offset function. Step 1. Begin by creating a table of data containing the data of the seller, vegetable and cost per kilo like this. Step 2. Implement the offset function where the reference pramod that lies in A4, the rows and cols are 2 and 0 respectively. The width and the height are both assigned the value 1. This will be the offset function. We can simply extend this to the neighboring cells by placing the cursor at the bottom right edge of the cell and copying the formulas to the adjacent cells. The only reason this works and does not return an error is due to the dynamic nature of the offset function. Let us implement this. Step 3. Vary the width and the height parameter of the offset function. This returns an error, but only because we are trying to return a range of cells to a single cell. To resolve this, simply use the offset function as an array formula. Press F2 and then Ctrl-Shift-Enter to use it as an array formula. Voila, it works. We can also use the offset function with other functions such as sum, diff, and many more. One of the more simpler use cases of the offset function is using it to create drop-down lists in Excel. Using drop-down lists in Excel is the most basic method to make worksheets interactive. While there are multiple ways to create a drop-down list, nothing uncomplicates the creation process like using the offset function. With the simple syntax that we've just so recently learned, creating drop-down lists is a piece of cake. Let us review the syntax for a little recap. We are aware of what each of these stands for. Now, what we need to understand is the different types: static drop-down list and dynamic drop-down list. Creating a static drop-down list using the offset function. Step 1. Create a table containing data of a variety of items, the total number of items, cost per item, and the total cost. Step 2. Create a table containing the name of vendor and the cost. Here is where we shall implement the static drop-down list. Step 3. Select the cell where we want to add the list. On the ribbon, access the Data tab. Find Data Tools and go straight to Data Validation. A dialog box like this should appear. Step 4. Under the Settings tab, select the Validation Criteria as List, which will then show us the source box. Here we need to fill in this formula. Let's break down the formula. $A$2 is the reference or base cell. Rows and columns are set to 0 as we do not want any offset. The height parameter is 6 as we have 6 items in the list. Step 5. Go to the cell and click on the arrow button to find the drop-down list. To apply this formula to the adjacent cells, place your cursor on the bottom right of the cell and drag the pointer. To make this interesting, we can add more columns and use the index match or VLOOKUP function to return corresponding values. Now that we are familiar with the static drop-down lists with the offset function, let's move on to dynamic drop-down lists. Creating a dynamic drop-down list using the offset function. Creating a dynamic drop-down list is an extension of the static drop-down list. What differs is the formula that we shall be using. Imagine if for the previous example, we add another item to the list. Would Excel update this automatically to the list, or would the new items get left out? Let's try for ourselves and see. Observe closely. I've added an extra row that contains data for the item souls. But if you look at the drop-down list, souls is nowhere to be found. Here's where the dynamic drop-down list steps in and saves the day. The formula does require the help of a COUNTIF function. So before we jump right in, let's understand the COUNTIF function. COUNTIF is used to count the number of cells that follow particular criteria. This is the syntax. In this particular use case, we could write the COUNTIF function in this way. To put it simply, we shall be making sure that the COUNTIF function passes all the non-empty cells within the range. Now that we have a basic understanding of COUNTIF, let us create a dynamic drop-down list using the offset and COUNTIF functions. Step 1. Create a table containing data of a variety of items, the total number of items, the cost per item, and the total cost. Step 2. Create a table containing the name of items and the cost. Here is where we shall implement the static drop-down list. Step 3. Select the cell where we want to add the list. On the ribbon, access the Data tab. Find Data Tools and go straight to Data Validation. A dialog box like this should appear. Step 4. Under the Settings tab, select the Validation Criteria as List, which will then show us the source box. Here is where we need to pay a little attention. This will be the formula for the dynamic list. Since we are using the COUNTIF function to look for all the cells that are not empty, ensure that there is no blank cell in the range. Having blank cells could lead to errors. Check the Apply the changes to all other cells with the same settings. This is an important step, or all cells containing the drop-down list will not be in line with the latest updates. Step 5. Observe how the drop-down list contains all the data from column A. Step 6. Add another item to column A and check the drop-down list. Here we have it. The list is auto-updated. That's all there is to dynamic drop-down lists. Of course, there are other methods to create a drop-down list, but using the offset function is by far the most uncomplicated and easiest way.